All right, welcome to Unit 5, Similarity, which is basically Chapter 7 from your book. So again, like last unit, it should be pretty easy to follow, but we'll get into that when we get closer to the end. All right, so this first lesson is pretty much going to feel like algebra class. We're headed towards similar figures, where we're talking about geometric shapes like these triangles here that have the same shape, but they have different sizes. So they're not congruent, but they are kind of predictably, you can find the size of one based on the size of another. There's some kind of scale factor in enlarging one to make the other. So a lot of that enlarging and contracting of shapes and kind of things has to do with multiplying and dividing, or applying ratios and proportions to things to scale them up or scale them down. In general, a ratio you can think of as a fraction. I like to think of a ratio as a fraction, but it can be expressed in any one of these ways. You could say the ratio of two things is 2 to 3 in any of these ways. You could read that 2 to 3 in any of these representations. And again, we usually go in simplest form. It's really not proper to say that something has a ratio of 2 to 4 or 5 to 10. It's not really illegal to do that. You just get laughed at math parties. You should probably say 1 to 2. As you know, like this one, I wouldn't call 4 to 6, even though those might be the numbers I would need to find that. I'm sure you're familiar with this before, reducing fractions. Our book also sometimes uses these extended fractions or extended ratios where we're actually comparing more than two things. So this ratio is just comparing 2 parts to 3 parts, sort of like one thing is 2/3 of the other. There's a way you can actually write that in 3 proportions, like a recipe with 3 ingredients, and you can use this representation to show how those 3 things stand in relation to each other. That's coming up a little bit later in the notes. Proportion, and people mix these up all the time, what a ratio is and what a proportion is. A ratio is just like what I was saying, a fraction. Proportion is an equation. A proportion has got 2 of those in there, and it's got an equal sign in the middle. When you're saying 2 things are proportional, or when things are proportional, we're saying they're in the same ratio as something else. So it really does mean that we've got 2 that we're comparing. And of course, they're equal. So that's maybe also why it seems like it's weird to think of them as 2 things, because they are equal, so why are they really different? But how we come to find them usually is or how we apply this is because there's really 4 elements in the whole problem. So we'll see that in a minute. But again, the word proportion means we're talking about 2 fractions that are equal, and the word ratio means something else. That is important when we come to tests, and it says write a proportion to describe blah, blah, blah. You got to realize when it asks for proportion, it's asking for 2 fractions that are equal. Okay, next, the red things here we call the extremes, and the blue things here we call the means. Not terribly important to remember that. The thing is, you know this probably from, again, 7th or 6th grade even. To solve this, if the fraction a over b equals c over d, you know the next step is what we usually call cross-multiplying. We say a times d equals b times c, and that's what's going on here in this next business. Sometimes I call it cross-product. I call it cross-multiplying. So if you see 3 over 5 equals 9 over 15, of course, there's nothing to solve here because it's all numbers, but that's equivalent to the claim that 3 times 15 equals 5 times 9. Anyway, the one that kind of goes this way diagonally is called the extremes, and the one that goes this way is called the means. I don't know if that's hugely important that you know which is which. I think of it this way. When I call it cross multiplication. The algebraic kind of theorem for that is usually called the means extremes property, and that's what we're doing here. So that's about it, is the name on that. Maybe when we get into geometric mean, you'll realize why this one's called means and this one's called the extremes. The thing that bothers me about this is if you were to write the fraction a over b equals c over d, that's really not mathematically profoundly different than writing it this way. A over b equals c over d. Now where's your extremes? Well, your extremes are here. Where are your means? Well, they're here. Does that mean there's something special about a and d? No, because here a and d were the extremes, here a and d were the means, so it's really kind of a left and right-handed kind of thing. It matters how you write it. So again, I really don't put a lot of importance into which is which. So I guess I should stop talking about it. All right, example 1. Find this stuff. Find the ratio of AE to BE. AE to BE, it's a ratio. I don't need to know any geometry going on in this shape to be able to answer this question. Find the ratio of AE to BE. Ratio, again, remember that's just one fraction. Find the ratio of, it's like they're asking this. Find or simplify or kind of solve for, write a better name for this fraction. AE divided by BE. Well, what's AE divided by BE? AE is 10. BE is 5x. I guess I should probably simplify that a bit. Here's some algebra review. That's the same thing as 2 over x. You can divide top and bottom by 5. Find the ratio of the smallest angle of DBE to the largest angle of ACE. Okay, these things are otherwise unrelated, but it's asking me for a ratio, so I can find that. What's the smallest angle of DBE? All right, DBE is here. Oh, I don't know what this one is. That's 68 and that's 38. There's 180 in the triangle. Okay, so 68 and 38 is what, 90, 106, is that right? So this would be 74. And then, so this one's also 74. Sorry that took so long. Check me on that, could be wrong. Smallest angle DBE, that would be 38. That's angle B. So that's, I'll put that, whoops, that's not angle symbol. That's 38. And the largest angle of ACE, that's 74. That's angle. Now, a lot of people are doing this on the test. You can't just call this angle E. There's too many angles at E. What do you mean by angle E? I should really use 3 letters here. Angle B was fine. There's only one angle there. But at E, there's too many. Excuse me. Oh, is this supposed to work out so nice? This is really half? Okay, I must have done that right then. All right, so now we're into solving. So now we're doing this means and extremes property, or cross multiplication. Just some algebra review, really. Make sure when you divide, or when you multiply along this diagonal, that times that, you're really multiplying the numerator of this times the denominator of that, which means you got to keep track of this grouping carefully. Put that in parentheses. The rest is not so bad. This is, I'm just going to set these up, then I'll pause and do it. Oh yeah, this one's a mess. Look at this. X plus 2, parentheses. Ooh, quadratic too. Yay. I'm going to pause and finish this one to save time. Actually, as I did that, I thought maybe I should explain what I'm doing. Remember distribution? We haven't really talked about that in a while. The distribution kind of ends when you get to this, and this is just 7 times 6. Yeah, and then I probably want to add 20 on both sides. And then I'm going to divide by -8. Yeah, this kind of stuff we just really haven't gotten so ugly in algebra for a while. Reduce this fraction, right? We said reducing fractions is a good idea. I think that's about as reduced as that gets. All right, then here's our quadratics. Okay, we've been reviewing systems kind of all year where you put them in the calculator and they just do them for you. Here's quadratics. Again, we could put this in the calculator. I'll do that next time. I feel like doing some algebra today. This is the difference of squares. I know how this is going to work out. Those middle terms are going to cancel each other out. Oh, maybe I should do this on the calculator. I feel like you're going to be confused. You know what? I'll do these on the calculator, and then I will... Oh, sorry, I'll do them this way, and then I'll... Oh, yeah, and those cancel, so that's it. That's 0. I can factor out an x. Oh, yeah, that's lovely. This has 2 answers. Okay. Yeah, that seems like something we should do on the calculator. Let me get the calculator out. Yeah, so if you don't want to believe that algebra, and I know some of you like to argue with me with this kind of stuff, let's put this into the calculator. So it's x plus 2 times x minus 2 equals 4x minus 1. Okay, so let me bring this over. All right, this one is not a system, so we can just get a good old-fashioned solve with algebra here. Oh, can I move this so you can see better what I'm doing? Oh, I can't move it. Can I move it, please? Please. Okay, that works. Now you can see all the buttons. All right, so I'm going to menu algebra solve, just regular old solve. And it was, careful with parentheses, x plus 2 times, do you need a times there? I'm not sure. X minus 2 equals, oh, and what did it equal? It equaled 4 times x minus 1. 4 times parentheses x minus 1. If you don't type that in just the same way it's supposed to be with the parentheses especially, it's not the way you want it. Now before I hit enter, I have to go comma x. This calculator is so fancy it will solve for, if I had more than one variable in here, it'll solve for whichever one I want. So it always wants to solve for what variable command, so you need the comma x at the end. And then it just does it. It tells you it's x equals 0, x equals 4. So if you didn't agree with my algebra, then, go back and look at that again. Okay, you can actually do that. I could have actually typed the solve command and typed all this in too. There's nothing wrong with that. In fact, x plus 2 over 4, check this out. Menu, solve. To do a fraction, notice it's right here. I can go control divided by, I get that. It was x plus 2 over 4 equals, I'm guessing, x minus 1. Whoa, I need another fraction, don't I? Control divided by x minus 1 over, I'm just looking at the thing above to see what that must have been, x minus 2, is that right? And then again, go out there and go comma x, and I get the same thing. So you didn't really even need to type in all that cross multiplying. A lot of times, though, this isn't always stuff you can type into the calculator. Like this might be the length of a side or something, and you can't really use you might not want to use a variable. So just realize that that's possible. Okay, measures of 3 angles of a triangle in the ratio 2 to 3 to 5. Okay, so there's this triangle, and the 3 sides are in ratio 2 to 3 to 5. So I mean, it might help if we draw this. I don't know. There's one angle that's the smallest angle. That's kind of 2/3 of the size of the next one, and that one's 3/5 of the size of the last one. Anyway, they all kind of relate this way. One way to think about any 3 numbers that are in the ratio 2 to 3 to 5, you can think of them in this ratio 2x to 3x to 5x. That means they'll all have this relative proportion. The 2 to 3 to 5, if you think about it in terms of fractions that are not reduced, if I double all those numbers, 4 to 6 to 10, I could also reduce them by dividing by 2, and I get back to this. So 4 to 6 to 10 is in the same ratio as 2 to 3 to 5. Same as 40 to 60 to 100. Ooh, and I almost did it there, actually. I almost got my triangle angles. 42 to 60 to 100, that is not quite right, because if those were the angles of the triangle, it would add up to 200. So I'm looking for the right scale factor to kind of raise this up until these also add to 180. So the quickest way to do that is to just solve this. I know that the 2 parts of something plus the 3 parts of something, or plus the 5 parts of something, where the part is always the same, that has to equal 180. Then you just solve this, which is actually so easy it doesn't seem like it ought to work. So what I should have multiplied was what? 20? How come that didn't work then? 2 to 3. Oh, because I didn't add this right. That's why. That's not 10, that's not 9. It's 10. You big mistake maker. Okay. 2 plus 3 plus 5 isn't 9. It's 10. So this should be 18. Right. So the 2 to 3 to 5, that tells me all these really should have been 18. So my 3 sides should have been 2 times 18 and 3 times 18 and 5 times 18. Those 3 numbers will add up to 180. So that's the angles of a triangle. All right. Here's different ways to write the same information in this proportion. This proportion is A over B equals C over D, the one we've been working with the whole time. Notice when you cross multiply, you get this. But realize that any of these other ways to write it, which is kind of like forwards, backwards, sideways, and upside down, would lead to the same cross multiplication. So if you're writing a proportion in your homework and you look up the answer in the book, in the back, and you wrote it this way and they wrote it kind of sideways, see why I call this sideways? It was A over B equals C over D, now this is kind of rearranged. Or you can write the whole thing upside down. Realize that might still be the same thing as what they wanted in the answer. So just because yours and your friends are sideways and upside down and backwards doesn't mean that they're wrong. Okay. We can stop fighting on that. All right, last page. All right, write equivalent proportions. So if this is what we're after, I know that x times 5 equals 3 times y. Oh, there's part of it right there, so I just need to fill this out. That equals 5 times x. 5 over y, oh, it looks like they're going sideways here. 5 over y should then equal 3 over x. You can't just write anything. Like I couldn't have written x over 3, but if you notice, you want to see if that works. This leads to what next step? 5 times x equals 3 times y. Oh, good. That's the same. Oops. Didn't mean to write on that. Y over x, that's just this flipped over, so I should flip the other one. Again, do the cross multiplication step and check it. 3y equals 5x, good. Remember this was all 3y equals 5x in the next step. Not bad having that for reference. 5 over 3, looks like, didn't I just say this? Let's look at my last one. Again, 5 times x equals y times 3. If you work for 2 weeks and earn $380, how much would you earn? 50? Yeah, this is the whole reason we do proportions. Think about dollars per week. Okay, I'm just going to talk my way through this first word problem. That's all there is. 2 weeks is $380. So I earned $380 in 2 weeks. So I'm thinking in dollars per week. It's kind of the way I'm thinking of it. $380 in 2 weeks is the same as how much in 15 weeks. Pause for algebra, and I just cross multiply and solve, and I get $28.50. Take a look at that if it doesn't make sense. All right, be nice to the sub if you're looking at one right now, and in any case, I'll see you next class.